Go. Okay, here we go. So what we're doing here is we are solving this equation. We're solving. One of the things that will be a key indicator, and if you remember, these are the problems that I had on the board on Tuesday. They were just kind of in the middle, review problems. And the directions to this one said solve. What is another way that you know you're supposed to solve this? The equal sign. Okay? The equal sign is right there, and that tells us that we are solving for a value. So here we go. What we're going to do first here is we are going to distribute. We're going to distribute that 3. Okay? So we've got 3 times 2x is 6x. 3 times negative 1 is negative 3. So we have distributed that 3. On the other side, I am going to leave it the same. I'm just going to bring down 2x plus 6 minus 5x. Okay? So my first step, I distributed. Now, for my next step, I am going to combine like terms that are on the same side. Okay? 2x and negative 5x can be combined because they're on the same side. 2x and 6x can't be combined because they're on opposite sides of the equation. So we are combining 2x and minus 5x. And that's going to give me negative 3x on the right-hand side of my equation plus the 6. Now I am just bringing down the 6x minus 3. Now, my next step is to move all of the variables to the same side of the equation. Move all the variables to the same side of the equation. So I am going to take this minus 3x. I am going to add the opposite of that. Okay? I add the opposite. I'm left with 9x minus 3 equals 6. Now, I have all of my x's on the left-hand side. Now I want to deal with that negative 3. Because I need to move that to the other side, I add the opposite. So I'm trying to eliminate that negative 3. And the way I eliminate it is I add 3. Okay? So negative 3 plus 3 is 0. So I'm left with 9x equals 9. Okay? And my last step here is to divide both sides by 9. So I have x equals 1. X equals 1. Now, I'm not going to check it, and I'm not going to require you to check it, but if I were to check it, what do I do? Good. That's exactly right. I plug the 1 in for everywhere I see an x. Everywhere I see an x. How do I know I'm right? How do I know that it checks? Good. They both equals the same. I get 4 equals 4. 0 equals 0. 10 equals 10. That's how we know that we're right. Okay? Okay, you're going to hear me say 1,000 times, can I move to the next screen? Okay, thank you. If at any time you need me to stop, don't hesitate. Let me know. Okay, this is number 2. And again, these are just those problems that were up on the board on Tuesday. So, that's where they come from. This is kind of a review week. We start the heavy lifting on Tuesday. And it's not that bad. It's not that heavy. Okay? So, this is a problem that has denominators. This is something that we forget. My daughter this is the kind of problem she texted me about and said, Mom, I feel like an idiot. And I'm like, you just forgot, honey. That's all you did. You just forgot. We are still solving because we have an equal sign. Now, if I was simply adding x over 2 and negative x over 5, I'd have to get a common denominator, and I'd have to rewrite those as a common denominator. Okay? But that's not what I have to do because I have this right here. Because I have the equal sign. I still have got to identify the common denominator. Then I just multiply everything by that common denominator. So between 2, 5, and 10, what is my common denominator? 10. Okay, and we call that the LCD. It's 10. So I am going to multiply everything by 10 over 1. Now, do you see that minus x over 5? Okay, that minus sign can give us headaches. It absolutely can give us headaches. So I want to change this to addition, and I'm going to move that negative sign to my numerator. So what's in front of that x now?
1.
Negative 1, because I've got that negative there. Okay? So I have changed it x over 2 minus x over 5. I have changed it to x over 2 plus negative x over 5. Okay? So now I've got 10 over 1. I'm going to multiply that times x over 2. Okay? And then I've got 10 over 1 times negative x over 5 equals 10 over 1 times 7 over 10. Okay. By design, this step gets rid of all my denominators. That's what we want it to do, is get rid of the denominators. Okay? So, I'm going to look at my 10 and I'm going to look at my 2. 2 goes into both of those. 2 goes into 2 one time. 2 goes into 10 5 times. So I am left with 5x. Okay? Now I'm looking at my 10 and my 5. 5 goes into both of those. 5 goes into 5 one time. 5 goes into 10 2 times. Now I am left with 2 times negative 1x. What is 2 times negative 1x? Negative 2x. Good. Good, good, good. So I'm going to get minus 2x. Then here we're like, whoo-hoo, I got rid of all my denominators. Now, 5x minus 2x equals 7. That's a whole lot easier to solve than x over 2 plus negative x over 5 equals 7 over 10. It's a lot easier to solve. 5x and negative 2x give me 3x. Okay. Divide both sides by 3. My x value is 7 over 3. So that is my final answer, 7 over 3. Okay? So for both of those problems, we had an equal sign. So we were solving. That's what we were doing in both of those problems. We were solving because we had our equal sign. You'll also know that when the directions were on the board, it said solve. Okay? Now, we are going to move into simplify. Okay? So our next couple of problems are going to be simplify. Simplify. Now, when we simplify, we're putting everything together. We're adding when we can add. We're multiplying when we can multiply. This is a binomial times a binomial, so we are going to FOIL. We're going to do a process called FOIL. FOIL stands for first, outer, inner, and last. It's typically one of those words we remember from high school. We don't always remember why we remember it, but we do remember it, okay? So it's first, outer, inner, and last. So what I do here is I do 3x times x. That's going to give me 3x squared. That's my first. Then I do outer, 3x times negative 4. That's negative 12x. I do 5 times x. That's 5x. 5 times negative 4. It's negative 20. Okay? Now, very often when we FOIL, we can combine those two middle terms. Not every time, but often we can combine those middle terms. So you always want to check. And in this situation, we can. We get 3x squared minus 7x minus 20. Okay, can I go to the next screen? Okay. Okay, now, this problem is a problem that students often will make a mistake because they get it confused with a different exponent rule. So I always like to talk about this problem. The wrong way to do this, is to just give that 3 to everything. Okay? So what we want to do is we want to say 2 to the third, a to the third, 5 to the third. Okay? And we like to turn in, 8a to the third plus 5 to the third, or 8a to the third plus 125. That is wrong. That is not what's happening here. Okay? It is wrong. Okay? The reason that you remember that, the reason that you want to do that is because of our power rule. And if I had 2ab to the third, if I had that all raised to the third power, then I would give that 3 to everything in there. I would say 2 to the third, a to the third, and b to the 3 times 3. That's what I would do. What is the difference between 2ab to the third? What operations are happening there versus what operations are happening in 2a plus 5 to the third?
Multiplication versus addition.
Absolutely, you're 100% correct. All of these are being multiplied together. That's why I just give that 3 to everybody. There's an exponent rule that tells us to do that. And we want to do that with that one. But we can't. Okay? For this one, it's addition. This rule doesn't apply. Okay? What we have to do here is we have to keep that binomial together. So I have 2a plus 5 times 2a plus 5 times 2a plus 5. Okay? I multiplied 2a plus 5 times itself 3 times. So the first thing that I'm going to do is I am going to FOIL these two. Whoops. So I have 2a times 2a, which is 4a squared. 2a times 5 is 10a. 5 times 2a is 10a. 5 times 5 is 25. Okay? Now that I have this trinomial, I've got to multiply this trinomial times this binomial. Think back to if I had 2 times 3 times 4. What's 2 times 3? 6. Okay? So I multiply these two together first and I get 6. Then I multiply the 6 times the 4. Okay? That's what I'm doing here. Now what this means is I've got to take this 4a squared and multiply it times 2a and times 5. I am distributing the 4a squared to my binomial. So I have 4a squared times 2a. That gives me 8a to the third. Then I have 4a squared times 5. That gives me 20a squared. Okay? So what I've done is I've taken my first term and multiplied it by the binomial, by both things in the binomial. Now, I want to do the same thing with 20a. I've got to say 20a times 2a and 20a times 5. 20a times 2a is 40a squared. 20a times 5 is 100a. Okay, and we've got one more. I need to multiply this 25 times my 2a and my 5. So 25 times 2a is 50a. 25 times 5 is 125. Okay? Now, I'm not done because I've got like terms that I can combine. So I'm going to start with my a to the third. Are there any other a to the thirds? No. So I'm going to write down 8a to the third, and I'm going to be done with that one. Now I've got a squared. Is there any other a squareds I can combine with? Good. So 20a squared and 40a squared is 60a squared. Okay? Then I have 100a and 50a. So that is 150a. And then I am left with 125. Okay? And I always check one more time. Is there any like terms I can combine? And remember, a like term has to be the same variable raised to the same exponent. Okay? Okay. Now, the next 4 or 5 problems that we're going to be doing are factoring. Okay? And that's what I want you to hit hard. I want you to hit the factoring hard. So, number 5 is negative 4x to the third, y to the fourth, minus 2x to the fourth, y to the third, minus 6x to the fifth, y to the second. So what I want you to do is I want you to think about factoring out the GCF. That is the greatest common factor. You are going to ask yourself, is there anything common to all of it? Is there anything common to every single one of those? Now, what I encourage you to do is look at the numbers first. Break it down. So we're going to look at the negative 4, the negative 2, and the negative 6. What can come out of all of those? Negative 2. Now, if you said, Alicia, I would just take a 2 out. They're all even, I would just take a 2 out. I would not disagree with you, okay? I would say that's legit. The reason I would take a negative out is because my first term is negative. That's why I would take a negative 2 out, okay? You don't have to. I can understand the plea that they're just all even, I'm going to take a 2 out. But the reason that I personally would take a negative out is because that first term is negative. Last class, somebody said, well, they're all negative. And that's true. That's another reason that you can take the negative out. Okay? So we are going to take a negative 2 out. Woo. Okay. So I have negative 2. So now we're going to ask ourselves, negative 2 times what gives me negative 4? 2. Okay, so negative 2 times 2 gives me negative 4. Negative 2 times what gives me negative 2? Good. And I'm going to do plus 1 right here. Negative 2 times what gives me negative 6? Good. And I'm going to do plus 3. So I have only dealt with my number. That's all I've dealt with. I've just dealt with my number. Now I want to deal with my x to the third, okay, x to the third, x to the fourth, and x to the fifth. So what you are looking for here is an exponent that's common in all of them. It's x to the third, x to the third. Okay, did you say y to the second? Yes, that's the next one. So we're going to focus on that x to the third. That's my lowest exponent. Okay? So I have x to the third can come out of all of them. X to the third times what gives me x to the third? 1. Be careful not to say 0 there, because x to the third times 0, what is that? 0. Okay, so it is x to the third times 1. X to the third times what gives me x to the fourth? X. Excellent. Good job. Okay, and x to the third times what gives me x to the fifth? Excellent. X squared. Okay, now our last one that we're going to look at is that y to the fourth. We've got y to the fourth, y to the third, and y squared. So we are looking for our lowest exponent, and our lowest exponent is y squared. Okay, so y squared times y squared gives me y to the fourth. Y squared times y gives me y to the third. Y squared times 1 gives me y squared. Okay, now I'm just going to write this all in the same color and multiply things out. So I've got negative 2x to the third y squared times 2y squared plus x times y plus 3x squared. Okay, and that is our final answer. Now, it is an excellent habit when you are factoring to ask yourself, is there anything that can be factored out of all of this? Is there anything that can be factored out of all of this? Excuse me, I'm so sorry. Is there anything that can be factored out of all of this? That's the question you ask yourself when you're GCFing, when you're greatest common factor. Okay? Okay, let's do another one. Okay. How many terms does this one have? How many terms? Look again. 4. 2xz is a term, 6x is a term, yz is a term, and 3y is a term. Okay? So those are individual terms. Maybe I should have said monomials. How many different monomials do we have? We have 4 monomials. When that is the case, always see if you can factor by grouping. Okay? Always see if we can factor by grouping. And when we factor by grouping, we put the first 2 terms together and we put the last 2 terms together. That's what we do. We just put them together. Okay? So I'm going to ask myself, what comes out of the first 2 terms? A 2 comes out of the numbers, okay, because a 2 goes into 2 and a 2 goes into 6, and an x. Good. There's an x in both of those. So we're going to pull out the x. Then I am left with z plus 3. Z plus 3. Now, what's common to the last 2?
Z or Y.
Y. Good. And so we are left with z plus 3. Now, do you see how this and this is exactly the same? You see how it's exactly the same? If it is not exactly the same, you can't factor by grouping, and we have to use synthetic division. And if you don't remember what synthetic division is, that's okay. We're going to do it in chapter 2. Okay? But that's what we focus on, is the z plus 3 and the z plus 3 being the same. That is one of our 2 binomials. That's one of our 2 binomials. So we are going to have z plus 3. Our other one is the 2x plus y. Okay? Now, how would I check that? How would I check it? I'd FOIL it. Good. I'd FOIL it. Now, what if I wrote 2x plus y times z plus 3? It's the same. It's the same. That's the same thing as saying 2 times 3 and 3 times 2. So you're good. It's completely the same. Okay, so that is factoring by grouping. Factoring by grouping. This next one is the factoring that everyone always wants to do. This is the one we remember. This is the one we like. This is the one that we get. And when I say factoring, this is probably the one that you think of. So we have x squared minus 2x minus 35. We are factoring a trinomial. When we factor a trinomial, this is our product. Okay, and this is our sum. It's our product and our sum. Okay, so my product here is negative 35. My sum is negative 2. And I ask myself, what two numbers multiply together to get negative 35? What two numbers added together give me negative 2? 7 and 5, and I heard which one was negative. Negative 7 and positive 5, okay? The reason the 7 is negative is because negative 7 plus positive 5 gives us this negative 2. Now, if you immediately said 7 and 5, you would get there. You just have to kind of play with the negative sign. You would totally get there, okay? Then, because and only because we have a 1 right there, we're able to just write those numbers in. So I have x minus 7 and x plus 5. That is because of this 1. If I have anything other than a 1 with that x squared, we can't do it that way. Okay? If I have anything other than a 1, we have to have a different method. But this method works when that's a 1 there. It's the method we remember, and it's the method that we want to use on all factoring. Okay? Can I go to the next screen? Okay. This is number 8. Number 8. 36a squared minus 25b squared. 36a squared minus 25b squared. Now, I want you to think about a squared minus b squared. I want you to look at a couple of things. This right here is a perfect square. Okay? What times itself gives us a squared? A. Okay? This is also a perfect square. What times itself gives us b squared? B. And this is subtraction. If that's not subtraction, all bets are off. Okay? It has to be subtraction. When we have this set up, we factor the difference of perfect squares. I have a plus b, a minus b. That's how that's set up. A plus b, a minus b. Okay? Now, our perfect squares are 1 because 1 times 1 is 1. 4 because 2 times 2 is 4. 9 because 3 times 3 is 9. What's our next one? 16 because 4 times 4 is 16. Our next one? Good. What's our next one? Our next one? 7 times 7? 8 times 8? 9 times 9? 10 times 10. Good. 11 times 11 is 121, and 12 times 12 is 144. At that point, you're probably going to reach for your calculator, which is fine. I mean, a lot of you probably have that memorized, especially 12 times 12. You might have it memorized. Anything over that, I have them memorized, but it's just because I teach it. So, most people don't have them memorized. What students forget, well, they usually remember that x squared is perfect because x times x equals x squared. What we forget about x to the 4th. X squared times x squared is x to the 4th. Okay? So don't forget about that one. So, what's my perfect square right there? Good. 6a. Good. The square root of 36 is 6. The square root of a squared is a. What's my square root here? 5. And then what's the square root of b squared? Good. Okay? So one of them is plus, and one of them is minus. Okay? That is the difference of perfect squares. You have to be able to identify that. And this over here is how you identify it. A perfect square minus another perfect square. If it's a perfect square plus a perfect square, you can't do it. It's not the same thing. It has to be subtraction. Okay, can I go to the next one? Okay. Now, this is the problem that gives students the most headache. Okay, and there's all sorts of different ways to do this. And I actually don't know the method that Dr. Lytle taught predominantly. What I will tell you is, I don't care what method you use as long as it's mathematically correct. There's a box method, there's an X method, there's a fraction method that I don't fully get, but I do know it's mathematically correct. I teach what's called the AC method. The AC method has the least amount of guess and check. It has the least amount of guess and check. Now, when students see this problem right here, they typically get their sum and product correct. My product, I have to multiply my A value times my C value. So I have to multiply this 4 times that 15. Okay? What is that? 60. Okay? Then what's my sum? 16. My sum is still that B value. Okay? My sum is still that B value. So I still ask myself, what two numbers multiply together to give me 60 and add together give me 16? 6 and 10. Those are the numbers. 6 times 10 is 60, and 6 plus 10 is 16. Now, what students want to do at this point, and this is where all mistakes are made in this type of problem, is they say x plus 6, x plus 10. Okay? Because that's how we did it when x was with a 1. Okay? That is wrong. X plus 6 times x plus 10 is wrong. Okay? Because we do not have a 1 there, because I have something other than 1, I split my 16. Okay? So if I take 4x squared plus 10x plus 6x plus 15, I have not changed the value of this problem. All I've done is I've split the 16x to 10x plus 6x. That's all I've done. Okay? Remember when we're foiling first, outer, inner, last, and I tell you that very often you can combine those middle terms? This is why. This is why we can combine them. So all we're doing is we're breaking them down. We're doing the opposite of FOIL here. We're doing the opposite of FOIL. Now, anytime I have 4 terms, what method can I use? Factor by grouping. Okay? So we're going to take what comes out of both of those, then we're going to take what comes out of both of those. Okay? So I can take a 2x out of my first 2. So then I'm left with 2x plus 5. What can I take out of my second 2? Can I take a 3 out?
Yes.
Good. And I'm left with 2x plus 5. So my answer here is 2x. Okay. 2x plus 3 and 2x plus 5. Okay? That's my answer. Okay, and I am actually going to stop right there.